Hello everyone to Northern's Craft. Today we are going to solve few problems of thermodynamics. Let's solve the questions and let's understand what questions ask for. Question number one says 5 meter cube volume of a rigid tank contains argon at minus 30 degrees Celsius, 3 megapascal. If argon has compressibility factor of 0.96, then the mass of the argon gas is in dash kg. Characteristics gas constant of argon is given as 0.280 and 2081 kilojoule per kilo Kelvin, kg Kelvin. So basically, we have to understand the concept of compressibility factor, which is equal to PV is equal to Z MRT. For ideal gas, Z is equal to 1. And if the value of Z is more than 1, then it's less compressible compared to ideal gas. And if it's less than 1, then it is more compressible. Graph of deviation of ideal gas behavior with respect to compressibility factor. PV open MRT. Somewhere here, let's consider this is Z is equal to 1. And as the pressure increases, when Z's value is more than 1, and when the pressure decreases. So, see, this is less compressible, this is more compressible. So this shows the deviation of real gas with respect to ideal gas, okay, with respect to pressure, okay. So now let's solve problem. So volume is given as 5 meter cube in question number 1, and at temperature is equals to minus 30 degrees Celsius, which is going to be 243 Kelvin. As we know, Kelvin is equals to Celsius plus 273. Then pressure is equals to 3 megapascal, which is going to be 3 into 10 to the power 3 kilopascal. And compressibility factor is given as 0.96, and R of argon is given at 0.28 2081 kilojoule per kg Kelvin. And the fact is, we need to find the answer in kg. That's why we convert P in kilopascal. Now let's solve it. Let's put it in the formula. We simply need the mass of the argon. Mass will be from the general formula, as we know the general formula. So mass will be PV open ZRT. Our P's value is 3 into 10 to the power 3, and our P's value is given over here, and then V is 5 meter cube, then Z's 196, and 0.2081 into temperature is 243 Kelvin. After calculating, try to calculate by yourself. After calculating, we will get 308.988 kg. This is the answer of first question. So now let's solve the second question. Second question says about the spherical balloon of a radius of 8 meter and is floating in the atmosphere. Hydrogen gas fill the balloon at 100 kilopascal. Pressure at which the balloon fills is 100 kilopascal, and temperature is 300 Kelvin. Number of moles of hydrogen is dash kilomole. Consider hydrogen as ideal gas. For ideal gas, the universal gas constant we know for ideal gas 314 kilojoule per kg Kelvin. So this is the general, like for ideal gas, universal gas constant will be like this. As in the question, hydrogen is considered as ideal gas. We need to find the number of moles of hydrogen. As we know the formula, PV is equals to, and yes, PV is equals to our PV is equal to our NR dash T. Okay, so our NR dash T, then value of N will be PV open NR dash T. So there's no compressibility value given over here, so we just need to solve this general equation. So we know the formula of volume of sphere, which is 4 by 3 pi r cube. So after putting the formula, we can see P into 4 by 3 pi r cube divided by r dash t, which is going to, our P's value is 100 kilopascal into 4 into pi into r's value is 8 cube whole divided by 3 into 8.314 into temperature is 300 Kelvin. So therefore our answer will be 85.985 kilopascal. Solve, just put the formula in this equation and directly solve it. It is simple like this. Okay, so now let's solve the last question, which is, it's now cylindrical tank. You need to know the few formulas, okay, like for to solve in thermodynamics, which is of sphere and cylinder. Volume of cylinder is pi r square h. So this is the volume of cylinder. Okay, so now let's find the formula. Well, let's find the solution. Cylindrical tank inside diameter of cylindrical tank is given as 20 centimeter. In thermodynamics, we generally use in meter, 0.2 meter, and 1 meter long. Length is given as 1 meter, and is evacuated and then filled in with CO2. Okay. If the mass of the CO2 filled is 1.2 kg, mass is given as 1.2 kg. Then and the final temperature is 25 degrees Celsius. Okay, final temperature is 25 degrees Celsius, which is equals to 98 Kelvin after converting it. And then the final pressure of the carbon dioxide is, we need to find the final pressure of carbon dioxide in kilopascal. Assume carbon dioxide to be ideal gas with, so our characteristic gas constant of carbon dioxide is given as 0.1889 kilojoule per kg Kelvin. So now we have to find the value of P. So as I've already said, PV is equals to MRT. So we need to find in this question is value of P. P will be MRT upon V. So V will be, our V is 20. It's already given. So pi by 4 d cube and d square. This will be the formula of into L. This will be the formula of our volume of cylinder. So pi by 4 into d square. Since it's given as not radius, that's why I'm putting like this. Okay, into L. Our length is given as 1 meter. So now after putting in the formula, where our given mass is 1.2 kg. 1.2 kg into value of R is 0.1889 into temperature is 298 Kelvin all divided by volume, which is pi by 4 into 0.2 square into 1. And after calculating the value, we will get 2150.203 kilopascal. This is the solution. So these are the 3 problems that we have done. Hope you understand. Thank you for watching this video and have a nice day ahead.